Okay, so our equipment has the function generator, oscilloscope, breadboard, and the capacitor and resistor. And the capacitance is about 61 nanofarad, and the resistor is about 1000 ohms. This is a charging and discharging graph simulated by using Python. The graph represents the charging process of a capacitor. When the voltage is set to 200 units, the capacitor charges until it approaches 200. In this experiment, the amplitude of the square wave represents the voltage I have specified. Conversely, during the discharging of the capacitor, it decreases from a high point to 0. In both the rising and falling process, the curve exhibits an exponential pattern. To measure the capacitor, we know that when t equal to tau equal to RC, V of t equal to 0.632 V max. By using cursor mode, we get a value of capacitor. In this experiment, we are going to observe how RC circuit works, including discharging and charging on a capacitor, and understand some methods to measure the capacitance value. Let's look how we connect the circuit. First, we use the T connector function generator. T connector split the output to the channel 1 and the channel 1 of the oscilloscope we measure, and the other is going to the circuit charging our capacitance. Here we look at the breadboard. The function generator input is connected on the capacitance and the resistor. The capacitor and resistor are connected in series. The channel 1 is channel 2 is connected on the capacitance both sides, this and this. And we finish the circuit. Let's look at the experiment 1. Observe the wave. In this experiment, the channel 2, the blue line, is represented the function generator inputs the square wave to the capacitance. Channel 1, the yellow line, is represented the capacitance value, voltage, as the input voltage increase. The capacitance starts charging, and the voltage increase in exponential. It means that the voltage starts rapidly and slow the end, and the voltage will not reach the upper bound. And the same as discharging, the voltage decrease in exponential too. The voltage will not reach the lower bound. This is because as time goes by, the exponential will close to 0, and it will not be 0.
So now we're going to measure the value of the capacitance. And to find out the capacitance with the oscilloscope, let's first measure the peak-to-peak voltage of the input signal. And so, as you can see, the peak-to-peak voltage of the input signal is 2.2. And use the equation, we can calculate the voltage of the capacitor V0. And we can see that at times equal to RC, which is time constant, V0 will be 0.632 times of input voltage. So we can measure time constant to get the value of capacitance. So as you see, the peak-to-peak voltage is 2.22 and the capacitance at time constant can be calculated at 1.4. So we can use the cursor of channel 2 and to get the point. And so as you can see, the time constant we can get is 64 microseconds. Okay, so now that we change the square wave to a sine wave, and this is how the charging and discharging look. And here the yellow one is the input signal, and the blue one is the signal of the RC circuit. And as the yellow one increases, the output signals from the capacitance is charging, and when the yellow one is decreased, the output signals from the capacitor is discharging. And yes, and so we can see that the input signal and the output signal are not overlapping, and this is because that there is a phase difference between the two signals. So you can see, and the capacitor value can also be calculated as the same method that has been used at square wave. So now we have to measure the peak-to-peak voltage of channel 1. And we can see that the peak-to-peak voltage of channel 1 of the input signal is 1.94 volts. And the capacitance at time constant can be calculated as 1.22. So we can use the cursor of channel 2 and as you can see here, the time constant is 197 microseconds. So now we have to try to use the Lissajous figure to find the capacitance. And first, we can use the measure mode to measure the frequency of the input signal. And as you can see, the frequency of the input signal is about 1.1 kilohertz. And if we switch to the Lissajous figure, we have to change it to the XY mode. And when we change to the XY mode, the channel 1 here will be the x-axis. So the yellow one will be the x-axis, and the white one will be the blue one, which is channel 2, will be the y-axis of the XY mode. And so now we change it to the XY mode. And you can see here is how the Lissajous figure looks. And to calculate the maximum voltage of the capacitance, we can calculate the height of the Lissajous figure. And to find out the maximum value of the input signal, we can be measuring the horizontal axis. And now, we have to use the cursor to measure the horizontal and the vertical voltage. as you can see here, the width of the Lithograph figure is about 1.86 volts, and the height of the Lithograph figure is about 1.74 volts. And after that, we can use the equation here to get the value of the capacitance. And now we are going to analyze the data of our experiment. And this is our result. And this is our data. And for using the equation, we can get that our capacitance is about 64 nanofarad. And we are using a 61 nanofarad capacitor, so we can get our error, which is 4.68%. So for this experiment, we are using the same methods as previous one, but we change it to the sine wave, and this is our equation. And for the equation, we can calculate the capacitance is about 290 nanofarad, but we are using a 61 nanofarad capacitor, so our error is about 375%. And this is quite obvious that the solution of ODE when AC source is in sine wave is not an exponential function. So there should be nothing to do with the value 63.2%. So the error is very big. And for the next experience, we are going to use the experiment mode to observe the Lithograph figure method. And these are equations. And these are data. And from the equation, we can get that our capacitance is about 38 nanofarad. And using a 61 nanofarad capacitor, our error is about 37.7%. And this is the experience that is not in the TA's video, but many groups use it. And so in this experiment, we are going to measuring capacitance using the time series method. And for the experiment, we use a 962 ohms resistor and a 0.1 microfarad capacitor. And using the equation, we can get that our capacitance is about 0.037 microfarad. And then we can get the error by calculate. And the error is about 63%.